Hello again, students. This is Mr. Liao, and these are the 2016 AP Micro FRQs. Number 1, the markets for bananas, muffins, and coffee are interrelated, and each market is perfectly competitive. A, in the market for bananas, the equilibrium price is $1 per pound, and the equilibrium quantity is 1,000 pounds per week. Suppose the government imposes a price floor on bananas at $1.20 per pound, causing the quantity supplied to increase to 1,500 pounds per week. Part A1, would the price floor result in a shortage, a surplus, or neither? Explain. So the price floor is binding because notice the price floor is above equilibrium. The price floor was at $1.20, equilibrium was $1. So the minimum price is $1.20, so it's an effective price floor. A binding price floor creates a surplus because the quantity supplied exceeds the quantity demanded. So remember, surplus or shortage deals with the quantity supplied versus the quantity demanded. Too often students write there's a surplus because supply exceeds demand. That is not what a surplus is. Remember, it is quantity supplied versus quantity demanded. Part A2, calculate the price elasticity of supply if the price increases from $1 to $1.20. Show your work. So there are a couple ways to do this. The general formula for the elasticity of supply is the percentage change of the quantity supplied divided by the percentage change in price. Now, how you calculate that percentage can be done several ways. First, we can use the midpoints, which is the more precise way. So the midpoint says that for the change in quantity supplied, it went from 1,000 to 1,500 for a change of 500 divided by the midpoint of 1,000 and 1,500, which is 1,250. So 500 was the change in quantity supplied divided by the midpoint of the beginning and ending quantity supplied of 1,250. We can do the same thing with price. The beginning price is $1, the ending price is $1.20, so the change in price is 20 cents. The midpoint between the two prices is $1.10. Now, if you do some math, you basically end up with an elasticity coefficient of supply of 2.2. Now, if you use the starting value, which you can also do, now you're basically looking at the percentage change in quantity supplied. It went up by 500 divided by the original starting quantity supplied of 1,000. You do the same thing with price. The increase in price was 20 cents. The original starting price was $1, which comes out to an elasticity coefficient of 2.5. So notice they're both over 2. The actual value is not as important as the fact that it's over 2. It's over 1. So remember, for elasticity of supply, it's always going to be positive because the percentage change in quantity supplied is always going to be in the same direction as the percentage change in price. 3, between $1 and $1.20, is supply elastic, unit elastic, or inelastic? Explain. So since the elasticity of supply is greater than 1, supply is elastic. And that's all you need to do to explain. Or you can say the percent change in quantity supplied is higher than the percent change in price. B1, bananas are an input for muffins. Draw a correctly labeled graph of the market for muffins indicating the equilibrium price and quantity, labeled P0 and Q0 respectively. So here you have your garden variety supply and demand graph. Remember, quantity on the x-axis, price on the y-axis. Don't get this confused with the macro graphs. Now on the graph, we're going to show the impact of an increase in the price of bananas on the muffin market, labeling the new equilibrium price and quantity P1 and Q1 respectively. So an increase on the price of bananas. Bananas are inputs for muffins. So an increase in banana prices means that costs increase in producing muffins, which means supply decreases. So supply shifts to the left, increasing the price and decreasing the equilibrium quantity. B3, on the same graph, completely shade the area that represents the change in the consumer surplus caused by the increase in the price of bananas. Now, consumer surplus is the area below demand and above the price. So the original consumer surplus is basically this triangle there. Okay, that's the original consumer surplus. Now, the higher price means that consumer surplus will decrease. So that green area represents the change in consumer surplus. The new consumer surplus is just this smaller triangle at the top. So the green area represents the loss in consumer surplus. Part C, in the market for coffee, the equilibrium price is $3 per cup and the equilibrium quantity is 100 cups per week. The cross price elasticity of coffee with respect to muffins is -2. Are coffee and muffins normal goods, inferior goods, complementary goods, or substitute goods? So you're given the cross price elasticity. Cross price elasticity deals with substitute versus complementary goods. And the rule is if cross price elasticity is negative, that means the goods are complementary, which is the case here. Coffee and muffins are complementary goods. If cross price elasticity were positive, they'd be substitutes. If income elasticity were positive, they would be normal goods. If income elasticity were negative, those would be inferior goods. So try to keep them straight. C2, assume the supply of coffee is perfectly elastic. Using the equilibrium price and quantity given above, draw a correctly labeled graph for the coffee market and show the impact of an increase in the price of muffins on the coffee market. So here's your quantity, price, and you have coffee supply being perfectly elastic, which means the graph is horizontal, and then downward sloping demand. The numbers are going to be explained in the next part of the question. Since the price of muffins has increased and coffee is a complementary good, the demand for coffee will decrease. So demand shifts to the left, and you can see that the price stays the same because supply is perfectly elastic, but the quantity goes down. The equilibrium quantity goes down. And those numbers will be answered in the next part of the question. C3, given the original quantity of 100 cups of coffee per week, if the increase in the price of muffins is 10%, calculate the new equilibrium quantity in the coffee market. Show your work. So cross price elasticity is the percentage change in quantity demanded of one good divided by the percentage change in price of the other good. So here we're given the percentage change in price for the muffins. We're going to be looking for the percentage change in the quantity demanded for coffee. We are told that the elasticity coefficient is -2. Price of muffin percentage change is 10%. Multiply both sides by 10%. And you see that the percentage change in quantity demanded for coffee is -20%. And since the original quantity of coffee was 100, 20% below that is 80%. So 80% of 100 means 80 cups of coffee. Number 2, Martha has a fixed budget of $20 and she spends it all on two goods, X and Y. The price of X is $4 per unit and the price of Y is $2 per unit. The table below shows the total benefit measured in dollars Martha receives from the consumption of each good. A, what is Martha's marginal benefit of the fifth good of unit X? So here's the fifth good of unit X. We notice that the total benefit has increased from $40 to $41 to that fifth unit, and that difference represents the marginal benefits. 41 minus 40 is $1. B, calculate the total consumer surplus if Martha consumes 5 units of X. Show your work. So remember, X costs $4 each, so thus her total price is $20. Now her total benefit is $41 from the 5 units of good X, and consumer surplus is the difference between what her total benefit is and how much she actually pays. So in this case, it's $41 minus $20 equals a consumer surplus of $21. And you have to show the work because the question tells you to show the work. C, Martha is currently consuming 4 units of X and 2 units of Y. Use marginal analysis to explain why this combination is not optimal for Martha. So to maximize utility, the last unit of each good, for the last unit, the marginal benefit per dollar has to be the same. Now, if you look at for good X, the final unit of good X for fourth unit gave her a marginal benefit of $4. The price of X is $4 for a ratio of 1. Now, for good Y, she's buying 2 units of Y. The marginal benefit of the second unit of Y is 18 minus 10 or $8, and the price of Y is only $2. So her ratio between marginal benefit and price is 4. Now, in this case, those ratios are not the same. D, what is Martha's optimal combination of goods X and Y? So let's calculate the marginal benefit for X by looking at the differences in total benefit, and then you're going to divide that by the price of $4 to get the marginal benefit per dollar. You'll do the same thing with good Y. Find the marginal benefit, and then divide each of those numbers by the price of $2 to get the marginal benefit per dollar. So what she's going to do, she's got $20. She's first going to buy 1 unit of Y because that has a marginal utility per dollar of 5. So that's going to go first. And if you just keep doing that, she's going to buy 1 unit of 5, then she's going to buy 1 unit of each X and Y. That'll leave her with $12. She's going to buy a second unit of X and a third unit of Y, which leaves her $6. Then she's going to buy a third unit of X and a fourth unit of Y for another $6. So her optimal combination is 3 units of X and 4 units of Y. If you notice, the marginal benefit per dollar for the last unit of each good consumed is 2. Part E1, indicate whether the price of good Y doubling will cause the optimal quantity of good Y to increase, decrease, or stay the same. So it will decrease because the marginal benefit per dollar for each unit of Y will be cut in half. So that 5 will become 2.5, the 4 will become 2, and that's obviously going to change how much of good Y that Martha is going to buy. E2, indicate whether Martha's income falling to $10 with no change in prices will cause the optimal quantity of good Y to increase, decrease, or stay the same. So the marginal benefit per dollar is the same, but now she has less money to spend. So her optimal quantity of good Y is going to go down. She just can't afford to buy as much because she has less money. E3, indicate whether Martha's income doubling and the price of both goods doubling will cause the optimal quantity of good Y to increase, decrease, or stay the same. Now, it turns out here it'll stay the same. Everything doubles, so her money doubles, the cost doubles, but notice the marginal benefit per dollar is not going to change, and she's still going to end up buying the same amount of stuff that she did before. Everything just costs twice as much, but she'll still be able to buy 3 units of X and 4 units of Y. Number 3, Camden's Cakery is one of many dessert cafes serving a local community. Each cafe produces a slightly differentiated product. There are no barriers to entry or exit, and the firm is in long-run equilibrium. A, draw a correctly labeled graph showing Camden's demand curve, marginal revenue curve, marginal cost curve, and long-run average total cost curve. Label Camden's profit maximizing output QM and price PM. So this is a monopolistically competitive firm, and they tell you that it's a differentiated product, and they tell you that there are no barriers to entry, easy exit and enter into the industry. So that tells you it's a monopolistically competitive structure. So looking at the graph, demand is greater than marginal revenue. Marginal cost intersects MR at the optimal quantity, in this case QM. You will go up to the demand curve to find the price, that's PM. MC intersects the minimum of LRATC in long-run equilibrium. LRATC is tangent to demand at the profit maximizing quantity. So this is the long-run equilibrium position for a monopolistically competitive firm. B, on your graph in part A, label the output at which total revenue is maximized, QR. Total revenue is maximized when marginal revenue is 0. So QR is the point where MR intersects the quantity axis, the horizontal axis. That's QR. C, do firms in this market experience economies of scale, diseconomies of scale, or neither in long-run equilibrium? Explain. So they experience economies of scale because long-run ATC is decreasing at the profit maximizing level of output. So economies of scale means at the quantity produced, LRATC is decreasing. If LRATC is constant, you're looking at neither. If LRATC is increasing, then you're looking at diseconomies of scale.